Hello, welcome to part something of this Further Maths Walking Talking mock. This is paper 2 from June 2015 and we're on question 24. So how much have we got left? 24, 25... Wow, this paper's really long actually. Well, let's just keep going. So, a squared is less than 4 and a plus 2b equals 8. Work out the range of possible values of b. Okay, let's deal with the a squared is less than 4 thing first. I mean, we can think about this logically or graphically. I mean, logically thinking, if a squared is less than 4, then a is going to be less than 2, but it's going to be bigger than minus 2, because minus 2 squared would also give 4, and minus 3 squared would give 9, which is too big. Thinking about it graphically, a squared, well, kind of looks like that, and for it to be less than 4, it would have to be in this section here, and that section is between 2 and minus 2. So I know a is between 2 and minus 2. And then a plus 2b equals 8. Okay, so let's put in the maximum and minimum values of a into this and see what values of b we get. So that would give b is 5. If I put 2 in, that gives 3. So b must be between 3 and 5. And it'll be non-inclusive because this is non-inclusive, and this was non-inclusive because that was non-inclusive. That's a weird question. 4 marks. It's very easy for 4 marks. 25. Work out the values of x between 0 and 360 for which 25 cos squared x equals 9. Okay. Right, let's start by just kind of simplifying this a bit. So I'm going to divide both sides by 25, and I'm going to square root both sides. Something that's kind of weird, when you square cos x, you don't write cos x squared, like, so it should really be that, right, when you square cos x, but for some reason we don't write that, we write cos squared x there. It's just a weird notation, but it means you work out cos x and then you square it. So square rooting it would give that, it wouldn't give like cos root x or anything weird like that. It'd just be like that. Okay, now I'm going to inverse cos. Which is 53.13. Okay, 1, because it wants 1 decimal place. But that's only one of the answers. So remember, 0 to 360. Cos graph looks like this. 90, 180, 270, 360. 53.1 is about there, and if we look across, there's going to be another value that also has the same y value, which is there. And you have to use a bit of symmetry. So if this gap from here to here is 53.1, then this gap from 360 to the left must be 53.1, so I'm going to have to do 360 minus 53.1. Oh, come on, I can do that in my head. 6.9. I mean 306.9. So the answer is 53.1 and 306.9. Oh, this question looks very familiar. It looks like that one that's on 9 to 1. It comes up every time. Okay. The curved surface area of the cone, please tell me we have the formula for that. Yes, we do. Pi RL. I should know that, really. Curved surface area of the cone equals the curved surface area of the hemisphere. Please tell me we have that. Yes, 4 pi r squared. So this is half, so 2 pi r squared. Yeah, the curved bit. It's obviously, the surface area of the hemisphere would also include the circle, but it says curved surface area. Show that L equals 2r. It's even like the same answer as that other question. Oh no, that wasn't 2, was it? That was a half. Same thing. Okay, so curved surface area of the cone is going to be pi RL, which is pi RL. I was going to substitute the radius and the length in, but there isn't any. Curved surface area of the hemisphere is 2 pi r squared. Okay, so pi RL equals 2 pi r squared. Divide by pi. Divide by r. And that's what we wanted. The cone has a vertical height of h. The cone and hemisphere are joined together to make that shape. Show that the volume of the shape can be written as that. A and B are integers. Okay, volume, I need some more formulae. So the volume of a sphere or hemisphere is going to be 2/3 pi r cubed. That's the hemisphere. And the volume of a cone is 1/3 pi r squared h. Okay, so the volume equals 2/3 of pi r cubed plus 1/3 pi r squared h. Right, and the answer doesn't have h in it. Does it say something about h? No? Okay. Where did the h go? Oh! L equals 2r. We're supposed to use that. That's 2r. So actually h, this is a right angle triangle. So h is going to be 2r squared minus r squared. That's 5r squared. No, it's not. It's 3r squared. So I could write that as root 3r. So let's replace that h with root 3r. Okay, let's just simplify it a bit. Like that, times the r's together and times the numbers together. Alright, let's, I'm looking at the answer now, and I know that it wants 1/3 and pi and r cubed all on the outside, so I'm going to take those all on the outside. So if I divide this thing by 1/3 pi r cubed, I'm just going to have 2. And if I divide this thing by 1/3 pi r cubed, I'm going to have root 3. Oh, there we go. Perfect. A and B are integers. Cool. Oh, it's the last question. Hang on a sec. I don't know if you can tell, but my voice is slowly dying. I've made so many videos today and yesterday, and I'm killing my voice. Work out the values of a when 2 to the a squared equals 8 to the a times 16. Do not use trial and improvement. That's harsh. I mean, I wasn't going to, but I mean, trial and improvement is a valid method of working any maths out, in my opinion. I mean, you could always use trial and improvement, like, you could write it on your desk, and they're not going to know. But I suppose you must show you're working, so you won't be able to get away with that. Alright, I've said this before, and I'll say it again. Whenever you've got an algebra involving indices, where the powers are the letters, you should always aim to make the base numbers the same. 2, 8 and 16, what they have in common is 2. So I'm going to make everything a base 2. So that's going to stay the same. I'm going to change 8 into 2 cubed. And I'm going to make 16 into 2 to the power of 4. Alright, now let's see. 2a squared. Right, when you've got brackets like this and you've got a power and another power, you times the powers together. So that's 3a. I've got that. And when you times two numbers together with the same base, you add the powers. So I can write that. Now I'm just going to remove the bases. Well, because, I mean, if you think about it, 2 to the power of that has to equal 2 to the power of that. Well, the 2's are already the same, so this must mean that a squared has to equal 3a plus 4. That's the only way that left and right are going to equal each other. So I get that, which is a quadratic equation. So I'm going to make it equal 0, and then I'm going to solve it in my favourite way, which is factorising. Minus 4 plus 1. So a equals 4 or minus 1. And you could just input those back in just to check that it works. If I put in 4, 2 to the power of 16 equals 8 to the power of 4 times 16. Okay, well, I can work it out. 8 to the power of 4 times 16. 65536. 2 to the power of 16 is 65536, so that works. And let me try minus 1. So 2 to the power of minus 1 squared, that's 2 to the power of 1, so that's 2. 8 to the power of minus 1 times 16, yeah, that's going to equal 2, isn't it? Yep, so it does work. So, I'm so tired. Thanks for watching this Walking Talking Mock for further maths. This was paper 2, June 2015, and not today, but sometime soon I will do another further maths paper and some more GCSE papers, but right now I need to rest my voice because I'm not used to talking this much, and this is why I could never be a real famous YouTube star. Anyway, I hope you had fun, and I'll see you, I'll see you next time.